and welcome again to this YouTube channel. So today we're going to make sense why actually we need to know about derivative. Okay, what's the point? All right. You actually I think already know about the limit. Okay, now we move forward. The very close friend of limit, the derivative or differentiation. Okay, how you're going to differentiate things. But before we move further, we need to see the rationale behind why. Okay, we need to know about the derivative. Okay, first thing first, if you want to know easier for you to understand, the first main objective of derivative is I can show it in a graph form. Okay, the most easiest way to look at it is on the quadratic forms. All right, so of course you know this is the quadratic form, and okay, when you need to find the vertex point. Okay, for example, like this one, you really want to know what is these values actually. Okay, and also what is this value is you can do either through your vertex point, or you can also use a way to solve it is to find the derivation, okay, the differentiation of y prime. All right, so for example, if this one you have just a simple one, for example, negative x squared plus 2. So you know how you're going to get this value. You differentiate this value, okay, and then you get negative 2x, right? And then you know instinctively, okay, based from your previous foundation, this is you equalize this equals to 0, and then you get the value, and then you know from this point onwards your x equals to 0, it should be over here. Okay, this is your x equals to 0, will imply a very maximum value for your y over here, right? So in this case, your y, you just put your value x equals to 0 inside your original value. Then you know if you have x equal to 0 as your maximum, as your critical, okay, critical point, in this case we call this, and then your maximum value now is, this is your maximum value. Maximum value now becomes uh, 2. All right, so the same thing happens for this one. Okay, what is the point of having a maximum or a minimum value? All right, so in a graph form you can see actually this is just like this is the maximum value, the point whereby all your neighborhood values over here and your neighborhood value for your this particular value here must be less than, okay, the vertex point. Okay, the same thing happen if you have a minimum point, all your neighboring values must be the lowest point. Okay, the lowest value is in the minimum point. Okay, the rest of the neighboring value should have at least greater than this particular value in my circle. Okay, so why I really emphasize on the neighborhood points, okay, because if let's say you have this particular graph, all right, it's a little bit weird, but then that's fine. Okay, just focus on point A and also on point B. See what happened? Point A is a maximum value. Point B also is a maximum value. But this one, if let's say I want to find the maximum value for my function, I will pick B. But is A maximum point? Yes, it is also a maximum point. So this is what we call a local maximum. Okay, and this one is a global maximum. Okay, so this is just an additional ideas, okay, why your uh, neighboring values for your x is very important if you want to really scrutinize what type of maximum or minimum value that you have. All right, so we move on to the application why. All right, this kind of importance of maximum and minimum value, you can translate your information on the graph in mathematical or in a real world application. Okay, it's because in a real world application, if you are able to transform your problem in real world problem into a mathematical formulation, you will only have a function. All right, and a function, you can always transform your function into y and x, for example. Okay, y and x meaning that a variables, two different variables put together. Okay, this is just a simple concept. First, we are not talking about different multivariables, x1, x2, x3, for example. Okay, we just assume now we are talking on two variables only, the dependent and also the independent variable, y and also x. All right, so what type of problems, okay, that we more or less use a lot of derivative. Okay, the first one is on your manufacturing problem. Okay, manufacturing means that if you want to produce certain particular product, you're not going to produce product that has no demand. Okay, or for example, you want to really make sure whether your demand is actually suit with your supply. Okay, that is the most basic things for you to consider. Why? Because if let's say your demand is high, okay, and your supply is low, that is not productive enough. All right, the same thing happen if let's say your demand is low but your supply is very high. You're going to get headache in terms of trying to coordinate your expenses and also your running costs. Okay, so we don't want that to happen. We really want to optimize, or we really want to maximize the profit, and we want to minimize the cost. Okay, so once you heard the words maximize the profit, meaning that there are certain variables involved to for us to utilize. All right, and you know that okay, by using dy dx, for example, in your quadratic formulation like this, you know this is your point where you are able to find the maximum values. Okay, the same thing apply for the relationship of a real world problem. Okay, so whatever happened to this flight, okay, the aeroplane that I have here, the same thing over here. Okay, for example, like you have the gas, okay, the kerosene oil that you use for the transportation, especially and in the aeroplane. That is why you need to really optimize the distance travel in an aeroplane. Okay, that's why sometimes if you notice the flight track, all right, some of the flight track, okay, they do it something like this. Okay, the aeroplane move further like this one instead of moving into the uh straight line. Why? Okay, why? Because they already make some adjustment on the modeling. It turned out the curve line sometimes is a little bit more economical compared to when you use the straight line. Okay, so there are lots of variables involved in identifying the optimized route for an aeroplane. Okay, a lot of variable. Okay, some of the variable include the uh, airspeed. Okay, and a lot more. Okay, it's another research altogether. What about the bridge? The construction of the bridge, this one is also very critical. Why? Because we are involved with a lot of resources for us to consider. Building a physical building a physical items under when you use this particular sea, okay, is not the same as you build in the land. All right, so the cost is huge, and it's larger compared to the traditional ways of doing things. So um, there are lots of costs involved in when you build bridge, um, we are not talking about the engineering part of it, okay, but we are talking more on the cost effective ways to build one bridge, for example. What about the racing car? Okay, there are reasons why people are so obsessed with the F1 V8, for example, race. It's not so much on the uh, adrenaline of it, okay, there is one other things, but it's more or less the most involved things for people to really move forward into this racing car is on the technology. Okay, so this is very important. If you want to make your car very very fast, you have to make sure that the oil is very efficient and the tire is very efficient as well. So the efficiency, once we have the word efficient, that's involved with lots of maximizing the performance and minimizing lots of different, for example, in the wheel, okay, the traction, okay, the traction of the wheel and so on. Okay, that's why we really really involved with extensive uh, investigation on the mathematical formulation. Okay, what about this? What is this? Okay, this looks a little bit weird, but this one represent the oil and gas industry. All right, so oil and gas all also is very very critical for you to utilize the optimization technique. Okay, why I mentioned optimization? Optimization is uh, the most significant concept that is so relatable to the concept of maximizing and also minimizing items. All right, so oil rig, okay, this is my oil rigs, okay, very critical. Why? One, you don't have that much resources, okay, and then two, the way you do the uh, investigation, okay, on where you're going to start drilling for oil, okay, that is also take a lot of extensive work and a lot of resources, okay, so you don't want to waste your resources on that unnecessarily. Okay, why there has two different people altogether here, okay, because I want you to also understand that this kind of equation, okay, or this kind of derivation does not limited to terms technical terms, meaning that the oil rig, the suspension of the bridge, the car racing facilities, and also industry or economical situation, for example, the manufacturing, but it also involves with the social aspect of life. All right, for example, how you're going to maximize the quality relationship between father and son. Okay, so if you are able to represent this particular relation, okay, very tricky but worth looking at. If you are able to simplify the messy relationship kind of behavior, then you are able also to identify the common factors. All right, so factors in that case is the variables, and then you can transform the variables into mathematical formulation, and who knows, you are able to maximize this kind of relationship based on the variables, which is your factors in hand. Okay, so this is some of the examples of how can we use derivation. Of course, it is not a straightforward ways to do that. There are lots of other factors for you to consider if you are interested to develop this particular model to answer six, for example, in this case, six problems that I have in mind. Okay, so I'll see you guys in the next lesson. All the best.